Discrete random variable. Let us now take an example of a distribution function. So let's revisit a die again. So the whole idea now is that we want to have a random variable and we want to find out which distribution do this random variable follow and which parameters do we need to describe this random variable. So if we have a die, so I'm gonna just put the outcomes into a table. So this is a very common way of denoting the probability space. What can happen will be described in this table. So the S is the states, meaning that these are the possible outcomes of the world. So in this case, we have 6 possible outcomes, meaning we have 6 states in the world. Each of them gonna represent the number of dots on the die. So when we roll the die, we're gonna end up in one of these 6 states. And each state represents either 1, 2, 3, 4, 5, or 6 dots on the die. Also note here that the P represents the probability. And since each outcome is going to be equally likely, we're just going to give it 1/6 of the whole probability space. And the whole probability space always sums to 1. Now the question becomes, okay, what kind of distribution does this follow? And I'm going to give you the answer directly. This is going to be a so-called uniform distribution, where we're going to have outcomes between 1 and 6. Yes, we can look into the mathematical definition of a uniform distribution, but I think at this stage, it's much more beneficial to just look at the distribution functions visually. So let's visualize this outcome space, or this probability space, this probability function. On the x-axis, we have the possible outcomes, the lowercase x's. So we have 6 possible outcomes, 1, 2, 3, 4, 5, or 6. The y-axis is the probability of each of these outcomes occurring. And since they all have 1/6 of the probability space, it's like 0.167 to happen. And as you note, it's a uniform distribution. Each outcome is equally likely. So just by looking at the graph of a probability distribution, it tells us everything we need to know about that random variable. Here we directly notice that we have 6 possible outcomes, each are equally likely, and nothing else is possible in this probability function. Another thing that we want to get out of this is where is the center mass? And this is something that we pretty much always look for when we work with statistics. What is the average effect? What is the expected value? So if we roll this die multiple times, millions and millions and millions of times, how many dots should we observe on average? Meaning, do we observe 2 dots on average, or 5 dots on average, or what is average? When we have the probability distribution graphed like this, it's very simple to get a feel for where the center mass should be. Personally, I think it's very simple to just start from the outside and then move inward. So if we look at the 1 and 6 outcome, we notice they are equally likely, which means that we should move the same distance into the middle. The 2 and 5 is also equally likely, so we should once again move the same distance toward the middle. The 3 and 4 is also equally likely, which means that we should end up somewhere in between 3 and 4. Which means that just by looking at the probability density, the probability function, we directly can see that the mean, the average outcome, should be 3.5 dots. So that means if we throw the die millions of times, we should have gotten 3.5 dots on average. So I hope this helps your understanding of what is a distribution function. And personally, I think visualizing is the key to understanding statistics. And the neat thing in statistics is that pretty much everything is built upon linear algebra. And linear algebra is very easy to visualize. So therefore, I'm going to focus on visualizing the concepts to give you the understanding you need to understand statistics. Next, let's visit another example of a distribution function.